You're going to be getting your Barbie ready for a big jump. You're going to be using rubber bands and data points in order to estimate how many rubber bands you need for a big jump. So you're going to have to measure from a high place how many inches it is. You will also need to use a measuring tape or a yardstick in order to collect your data points. You're going to use these data points and you're going to plot them on graph paper. Then you're going to draw a line of best fit. You're going to find the equation of that line, and then you're going to use that in order to estimate the number of rubber bands you're going to need for your Barbie to take the plunge. Okay, so the first thing you need to know is how to attach two rubber bands. So what you're going to do is you're going to kind of make a Venn diagram with it, and then you're going to take the bottom one and fold it over, kind of like a rubber band sandwich. Then you're going to stick it underneath that same rubber band. So you lift that up and put it underneath. You're going to make something that looks kind of like a Mickey Mouse and then slowly pull it. Now you've attached two rubber bands. It's really important that you only attach one rubber band at a time. Don't try to make a big long chain and then try to attach it. Just one at a time. Once you have your two rubber bands attached, you're going to attach them to your Barbie doll. Use one of the rubber bands and wrap it securely around her feet. So it looks like this. Now this counts as one rubber band. Next you need to find a place where the Barbie can fall off of. So you're going to set the Barbie up and then you're going to let the Barbie fall down and you're going to measure the lowest distance the Barbie fell. This is your first coordinate point. One rubber band and the inches the Barbie fell. 1, whatever inches you measured. The next thing you're going to do is attach two rubber bands and you're going to set your Barbie up again. Now notice my thumb is on the rubber bands right next to the edge and the Barbie's feet are right there. I'm going to let the Barbie fall and measure the distance the Barbie fell. This is our second coordinate point. And I want to measure the lowest distance. So where the Barbie goes the lowest. Okay, so if you're measuring the distance, you can measure the distance of the object the Barbie's going to fall off of, and then using a yardstick, you can measure how far down it went. So in this case, 18 inches, that's what those dashes mean. So to find that distance, that blue distance, you just take the total distance, 70 minus 18 inches, and you get 52. Now eventually, you'll have a set of data, and you want to record this in a T-chart, where one side, your X, equals the number of rubber bands, and Y equals the inches that have fallen. Once you have this set, these are your coordinate points. If you want them to be more accurate, you can do each measurement different times. So try two rubber bands several times and average them. Here are some examples of data collection.
Oh, probably should talk to somewhere else because it's getting down to 3.
Yeah, it's exactly that far.
One. Go grab this and check measure and everything else.
Let's say about 47 inches. See? Let's just say that.
I'd say about 48.
Okay, so we have about an average. Oh, sorry. The average is 28. 26.
Yeah, I'd say about 48.
That's a good spot.
Again.
29.
Okay, that was like 22.
It's like 23. Let's say 23 to be safe.
Barbie. You ready? Yeah. Alright, so that was about like 59.
Oh, this rubber band's tight. Watch it, Johnny.
That looked like 1.
1? Let's try it again.
That looked like 1 to me.
Yeah, I did. It was 1.
That was 1.
52.
Try it again and try to make it so it doesn't hit stuff on the way down, because then.
52.
Oh wow.
How far did it go?
Right here.
31 inches.
46 minus 1 foot.
1 foot?
Once you have your data points, you can plot them on a coordinate graph. You'll have to be careful on how to label the axes. You can see that the rubber bands, actually we're only going to 10, so that needs to be short. So we're actually putting the paper the long way. And the inches falling, you need to go at least to 60 because of our data point. So I chose to count by 2s. We're going to have to remember that later when we calculate the slope. So once I have the data points, I can draw what's called the line of best fit, which right now I'm just eyeballing it. Later in statistics, you'll learn the best way to draw this line, but I'm just sort of looking at what about it is. Now notice the line's not zigzag, it has to be a straight line. And I'm going to use this line to calculate the slope and come up with a formula in order to predict how many rubber bands I'm going to need for the big fall. Now looking at my line, I can see the y-intercept right over here. So that's my y-intercept. Now this line contains some of the points, but not really exactly. You can see some are above and some are below. So to calculate the slope, I need exact points on this line. So I'm going to look for where those lines cross. And there's one right here at 5.5, comma, that's at, let's see, each one goes by 2. I need to remember that. So that's 32, 34. So that's 5.5 comma 34. That's an exact point. Now over here I can see that line crosses right there where that intersection point is. That makes it easy for me to know the coordinates. And that one is right at 6.5. And I say 6.5 because notice on my x-axis, I am going by 0.5s, not by 1. And that's at 40. Now I can use those 2 points on the line. Notice they're not my data points. They're just 2 points that are on that line to calculate the slope. The slope is delta y over delta x. Now I need my change in y. So I'm going to take 40, that's where I ended, subtract where I started, 34, and that's going to be over my change in x, which is 6.5 minus 5.5. That's the change in y over the change in x, or my slope of this line. So that is 6 over 1. So my slope for this line is 6. Now what that means is I fall 6 inches for every rubber band. So each rubber band has me fall 6 inches. That is my rate. Okay, so I can come up with an equation for my new line. I know y equals mx plus b is the slope-intercept form. I know what m is. M is my 6. I can put that in for m right there. And I need to know my b. That's my y-intercept. And what I can do is look at my graph and figure out what that b is. So if I look at it, it's a little over 12. I would say 13. So we're going to approximate that b, my intercept, at 13. Now, what does that mean? Well, at 0 rubber bands, the Barbie's going to fall just the height of the Barbie. So my b actually is my height of the Barbie. And if I were to measure my Barbie, I'd find she's about 13 inches. Now I can use this equation for the big jump. The big jump I measured at 160 inches. I'm going to put that in for y because y is my inches fallen. And I want to figure out how many rubber bands I need, my x. So now I can just solve for x. I subtract 13 from both sides. And I get 147 equals 6x. And I'm going to divide both sides by 6 to solve for x, the number of rubber bands. So 147 divided by 6 is about 24.5. So that's how many bands I need. Now, do I want to overestimate or underestimate? Well, remember, I am bungee jumping, so I want to make sure it's not too long. So probably rounding up to 25 might not be a good idea. So I'm going to estimate 24 bands in order to go 160 inches. This is what I'm going to use for my big jump. Now you're going to attach 24 bands one at a time to your Barbie. Now before you do that, I want to show you another way we can calculate the slope, and that's just using our 2 points. So I can take this point, this coordinate point, which is 1, 16, and this coordinate point, and I can find the slope. So first, let's just write down all of the coordinate points so you can see them as ordered pairs. All right, so now I want the change in y over the change in x. Now my change in y is just 21 minus 16, the y coordinates, over the change in x, 2 minus 1. And my slope is 5 over 1, or just 5. Now, I can do that with these ones too. I can take 25 minus 21, my change in y, over 3 minus 2, which is also 1, and I get a slope of 4. So it's looking like between 4 and 5 rubber bands per inch. Can do it with this one as well. 30 minus 25, my y's, and 4 minus 3, my x's, and I get another change of 5. Now, let's pretend like we didn't take measurements for 6 and 7. We can take the slope of these 2 points. So the change in y is 48 minus 34, that's my change in y, over 8 minus 5. And that equals, my change in x is 3, and my change in y is 14. Okay, and that's about equal to 4.7. It's approximate. Now let's pretend like I didn't take any other measurements. I can use these measurements to calculate an average slope. I'm just going to add all my slopes together. 5 plus 4 plus 5 plus 4.7, all divided by the number of slopes, which in my case is 4. It could be a lot more, but in this case it's just going to be 4. And I'm going to go ahead and do the math. The numerator is going to give me 5 plus 5, 18. 18.7 over 4. Using a calculator, I find that's about 4.675, which is about 4.7. Now that's different than my 6 slope, so I need to choose which of these slopes to use in order to make my best estimate. So let's go ahead and take a look at both of our slopes. So for this one, when I just used my line of best fit, I had an equation that looked like y equals 6x plus 13. Now the question is do I want to replace that 4.7 in there for the 6? So my other slope was 4.7. Now let's think about our Barbie bungee jumping. So if I have a larger slope, that's going to mean I'm dividing by that 6 in order to solve for x. That means I'm going to have less x's or less rubber bands. If I have less rubber bands, I have less of a chance of Barbie falling too far. So I'm going to use the greater slope just to be cautious, because in bungee jumping, you really don't want to overestimate the number of rubber bands. So even though my slope gave me a good idea, my averaging of my slope, I'm going to choose to use my line of best fit slope in this case. So using a prediction, now I attach those 24 rubber bands, and you're going to do the same. Your rubber bands will probably be different. And then Barbie is ready for her big jump. Go ahead and get her ready and see how your prediction works out.
In the Barbie world.
Okay.